Hello everyone. In this video I will cover Python advanced concept. I will be covering all these contents in this video with a real world example. So I will be going through the slides and also I will be doing code for each of these topic. So the contents are decorator, generators and iterators, metaclasses, multithreading and multiprocessing, and also I will be doing async programming and context managers with statement. So without any delay, let me explain about decorator. What are decorators? Decorators are nothing but a special type of function that allows you to modify or enhance the behavior of other functions or methods without changing their code. That means, suppose if you have defined one function and if you want to change the behavior of that function, then you can define decorators. And this decorator will take another function as input and it will return a new function. It will add some functionality or it will change the behavior of that function. You can use decorator for logging purpose to track function calls or data, and for authorization to check if a user has permission. We will be doing this part in this video, means I will be implementing decorator for this authorization. And next one is for timing, that means to measure how long a function takes. And for caching, store results to avoid repeated work, and for validation to automatically check input or output. Okay, I will explain through the code. You have to first define your function and you can define then decorator to change the functionality or behavior of that function. I will define very simple function with a def keyword and the function name is view dashboard. I will print very simple message, welcome to your dashboard. Okay, this is our function and I would like to change the behavior of this function. I am implementing authentication here. That means not all the users are allowed to see this message. So I would like to add some authentication here. So suppose here I will define user session and this session is my object. I will be having user here. Suppose right now initially it is none. That means no users will be allowed to see this message, welcome to your dashboard. I would like to change the behavior of this function, and for this now I have to implement decorator. Now my decorator code starts from here. Suppose my decorator function name is login required. I want to implement if the user has login, then only he or she can see this message. As I have already mentioned, this decorator will take function as a parameter. I will be implementing decorator in this function, so this function is view dashboard. So I will be passing function as a parameter. Inside this I will be having another wrapper function, so I can write wrapper. It will take args and quarks. That means argument and keyword argument. Right now there is no any argument and keyword argument here, so this will be empty, but you have to pass this argument and keyword argument while you are defining decorator. Now I will check if my user is in this session or not. So I can write if session.get user. If there are user, then only I can write ss granted to session user username. I am passing this function as a parameter. So now here what I can do is I can simply return this function argument quarks keyword argument. That means if the user is accessed, then only I am calling this function. You will understand once I complete this function, so don't worry. If the user is not in this session, I can write this. If not, I can print this message. access denied. Please log in first. I can return none. That means I will pass this view dashboard function here in this decorator. If the user is SS, then only I will be calling this function. So I am returning that function. If not, I will return nothing. That means the function should not be called if the user is not assessed. And finally, I have to return my wrapper function also. Okay, this is completed. This is my decorator. I would like to use this decorator in this function. So I can simply write here iterate and my decorator name. My decorator name is login required, right? Now when I call this function, it will go to this decorator and it will check if the user is assessed or not. If assessed, then only it will display this message. That means it will go to this block and it will display this message. But if the user is not allowed, it will return none. That means our execution will not go into this block. Now let me create another function here. If login, it will take username. To insert user in this session, I am making this function. I can write session user username will be this username. Okay, I can also print one message. User, this username is, or user username logged in. I can print this message. This is my login method. Now I can have another method for logout. And in this logout, I can simply write user equals none. That means now the user is not in this session. Same like this. I can print here user logged out. Okay, now the code is completed. So if the user is login, then the user will store in this session, and then if I call this function view dashboard, then only the user will be allowed. If not, suppose if the user is not logged in yet, then it will go to this block. That means when you call this function, you will not get this message. Let's test this. So here, first of all, I am going to call this view dashboard function, and now if I click on shift enter, you see access denied, please log in first. So user have to log in. Now I am calling this login function and I am providing one username, suppose Alice. Now if I shift enter, you see user Alice logged in. Now the user Alice is logged in. Now if I call this view dashboard function again, switch enter, see it will say access granted to Alice and it will display this message, welcome to your dashboard. And also I have implemented this logout function. I can call this logout function and it will clear the user from the session. So now if I click shift enter, you see now the user is logged out. Now if I call view dashboard function again, it should be, the user should be denied again. Shift enter, you see it is denied, please log in first. So we have implemented our decorator and this is our main function, but we have changed the behavior of this function. That means this is the separate implementation. When you call this view dashboard function, it will not go into this print block, but it will check if the user is allowed or not. So to display timing, to check the authentication, and for different purpose you can use decorator. If you want to separate some logic from your function, you can use decorator. So decorator is very useful. Next we have generators and iterators. So what are these iterator and generator? You can see here Iterator, it is a custom object with iter and next methods. That means iterator will use this method iter and next, and it requires manual state management, and it will ideal for complex iteration. We will see this in the code example, but you have to understand that this iterator will take two methods, iter and next method, and you have to manage state by yourself. We will understand this in the code example itself. And what is this generator? Generator is also a iterator, but you don't provide this iter and next method in this generator, but you will use this yield keyword. So the generator, it is a function with yield that automatically handles state, making it simpler and more memory efficient for generating values lazily. So both of these iterator and generator are used for iterating object. The difference is you have to provide iter and next method in this iterator, and in this generator you have to use yield keyword, and behind the scene it will automatically use this iter and next method. You don't have to provide by yourself. And in this iterator it can consume more memory as it stores data, example in list for iteration. And in generator it is more memory efficient as it generates items one at a time and doesn't store all data in memory, ideal for large datasets or infinite sequences. The use of this iterator and generator are almost same, but the difference is the syntax you use while defining this iterator versus this generator. And another is the memory is same for this iterator and generator, but if you want to store some data in a list, then it can consume more memory. That means this iterator can consume more memory, whereas this generator can store data in fly. So it is more memory efficient. I know looking at this slide it will be difficult for you to get what iterator and generator actually is, so I will dive into the coding part now. Okay, let me write here title. First one is iterator. I will be implementing API pagination. I will be making one class with the name API pagination. This class will take init method. When you create your object, the first function that is called is init method, and it will take self to locate current instance. And also let me pass here total pages. It will take total pages. I can write self dot current page equals 1. This is the default value of this current page, and total pages equals total pages. As I have already mentioned, this iterator will take iter and next method, so I will be implementing iter method now. Iter, I can return self. Next I will be having next method. Here I can write if current page is less than or equal to total pages, I can return this data, fetch data from page and the page number, self dot current page. Self dot current page, I can increment current page by 1, and I can return this data. I can check if the current page is less than or equal to total pages, and if it is, then I can return this message, fetch data from this page, and I can increase the value of this current page by 1. Else I can raise stop iteration. Now let me print one message here. Now my class is completed and I'm going to use this API paginator class. So I'll be using for loop here. I can write for page data in this API paginator. I'm directly passing this API paginator in my for loop, and it will take You can see here it will take to 12 pages. Let's suppose total pages is 5. I can print this page data. So the iterator is used for iteration, and I have created this class. What will it do is it will take this iter and next method and it will iterate my pages. And I have currently 5 pages, so it will display page data from page 1, 2, 3, 4, 5. If I press shift enter, sorry, I have to use curly braces, not parentheses. Okay, shift enter. See, it will fetch data from page 1, 2, 3, 4, 5. So this is a very simple code. Right now, after fetching the pages, it will not do anything, but this is how you can implement iterator. In this iterator, you have to remember there are two methods, that is iter and next method. And why this iterator used for? If you want to iterate multiple or large data, then iterator will be useful. You have already list or array in Python, but that list or array will load all the data at the same time. Suppose if there are large amount of data, then you have to use this iterator. Iterator will fetch data one row at a time, or you can use generator also. I will be implementing generator now. Now I will be converting this iterator, this API paginator in generator. That means I will be implementing same logic through this generator. So I will be having one function, suppose API pagination generator, and it will take total pages. And here let me initialize this current page equals 1, and while this current page is less than or equal to my total pages, I can display the same message. As I have already mentioned, in this generator you have to use yield keyword, yield. You have to use this yield keyword, and in the backend it will automatically use that iter and next method, so the code will be refactored and you don't need to provide that function by yourself. You can write the same message from page current page, and also I can increment this page by 1. Okay, this is completed. Now to call this API pagination generator function, let me first print one message, generator output, same like as above. I can write for page data in my function API pagination generator, and it will take total pages. Let me pass 5 again, and I would like to print this page data. So the functionality is same to display this page data with this iterator and generator, but you can see here the amount of code you use for this iterator is very high, but for this generator you can see here the code is very simple. That means the code is more refactored in this generator. You can use this yield keyword, and this yield will take one data at a time. So you have to first understand why you are using this iterator and generator. You are using this iterator and generator to load one data at a time. Suppose in Python you have a list or array. List or array will load all data at a time, and for suppose if there are large amount of data, then you have to use this generator or iterator, and it will fetch one data at a time. So now if I press shift enter, see the output is same, fetching data from page 1 to 3, 4, 5. When to use iterator or generator? You have to use iterator when you need more control over the process, like when you want to handle state, provide more complex logic, or manipulate the data between pages. You have to use iterator. And you can use generator for simplicity and efficiency, especially when you are just fetching or generating data on the fly, such as I have already implemented this API pagination generator. You can see here This iterator takes iter and next method, and you can add your own logic here. You can manage state by yourself, but in this generator you can use yield and it will generate data on the fly. So you don't have any control using this yield keyword. If you want more control, you can use this iter or next method. And why not to use a list or array? Because list or arrays load the entire dataset into memory, and that may not be feasible for large data. Suppose if you have 100 GB of data, then list or arrays may not be useful because it will load the entire dataset into memory. But iterator or generator only keep track of one item at a time, and it will reduce memory usage. So this is all about iterator and generator. Next we have metaclasses. We have already covered decorator. Decorator changes the behavior of the function, right? In the same way, this metaclasses will change the behavior of your class. So in Python, everything is an object, even classes themselves. And you can say metaclasses is the class of a class, and it defines how classes behave. Decorator defines how functions behave. In the same way, metaclasses defines how classes behave. Normally, we create objects from classes. With metaclasses, we create classes from metaclasses. So the flow is metaclasses creates class, class creates object. And the default metaclasses in Python is type. You can use this type. And when you define class like class my class, Python actually does this. It will use a type keyword. So this is just like decorator. Decorator is for function. In the same way, metaclasses is for class. Let's implement this metaclass. First of all, let's implement without metaclass. Metaclass will change the behavior of the class. Without metaclass, let me define one class. I can define any attribute here. I can define API key equals 1, 2, 3, and suppose timeout. Suppose I want to change the behavior of this class. Right now I am defining two attributes, API key and timeout. If you see here, this API key is all lowercase and this timeout is uppercase. So there is no any rule here. If I press shift enter, it will work because there is no any rule. There is no any meta class added. I would like to implement one meta class. That means I would like to change one rule. Say you are not allowed to define attribute in lowercase. Let me write title here with meta classes. I would like to define one meta class, and the name is suppose uppercase attribute meta. I want my attribute to be all uppercase. I have already mentioned meta classes. The default meta classes is type. You have to use type. And here I'll be defining one function that is new, and this new function will be called when you create your class, and it will take CLS name basis and class dictionary, and this class dictionary will take all attribute you have defined, API key, timeout. So I have to look through this class dict. I can write for attribute in class dict. I have to check if this is my uppercase or lowercase. I can write if not attribute, if my attribute not starts with double underscore. If not, my attribute starts with this. This is an exceptional case. And now, if not, my attribute is uppercase. In this example, this API key is not in uppercase, so it will go into this if block. I can throw the type error. I can write attribute, my attribute name is not uppercase. I can return super.new. I've written this new method. So if my class contain attribute all in uppercase, it will not throw any error. It will return, it will call this class. Otherwise, it will throw this type error. Here I am going to use this meta class in this class. Let me create class again. Same class config. And to use the meta class I have created, I can pass it here equals my meta class name. And now let me define API key here equals 123 and timeout equals 5. Now we have press shift enter. Str object has no attribute starts with. Okay, so this w should be small, so I have to write here small w. Let me press shift enter again. Okay, you see there is no any error because my attribute follows the rule. These attributes are all in uppercase. Suppose if I create another class, suppose with name bad config, and again I'm using the same class, same meta class, and here suppose if I provide timeout equals 5, and if you see here this timeout is in lowercase. Now if I press shift enter, you see it will say attribute timeout is not uppercase. I have changed the behavior of this class. So I have used these meta classes and I have changed the behavior of this class. So same like decorator, I can implement this meta class for class, and it will check if my attributes are in uppercase or lowercase. It should be uppercase to pass this rule. Okay, I can implement meta class in this way. You have to remember object is an instance of a class. Class is created by a meta class, and meta class defines how a class is created. And also you have to remember the default meta is type. You can share I have already defined type, so this is the default meta. Next one is multi-threading and multiprocessing. Both of these multi-threading and multiprocessing are two ways to achieve concurrent execution, meaning your tasks can run at the same time to improve performance, especially in complex or time-consuming programs. So if you want your tasks to run at the same time, you have to remember the concept multi-threading and multiprocessing. And what are the difference between multi-threading and multiprocessing? You can see here. This multi-threading is a IO bound task, means for web scraping or crawling API calls you can use multi-threading, and for CPU bound tasks, example image processing, you can use multiprocessing. And the main difference between multi-threading and multiprocessing is, you can see here, threads. This multi-threads share the same memory space, but this process has separate memory space. So when you run your tasks, means in multi-threading it will share same memory, but in this multiprocessing it has separate memory. And in this multi-threading it will be affected by Python global interpret lock, but in multiprocessing it will not be affected. So this multiprocessing is truly parallel execution. So you have to understand this global interpreter lock. That means even if our computer has multiple CPU cores and our Python program creates many threads, only one thread can run Python code at a time because of this global interpreter lock. Because of this GIL effect, multi-threading may not behaves like a truly parallel execution. Let me explain through the code. Let's see how can we implement this multi-threading and multiprocessing. So if you want your tasks to run at the same time, you can implement this multi-threading or multiprocessing. So first one is multi-threading. First of all, I would like to import threading, and also I would like to import time. And let me create one function, find square. It will take number as parameter. And for I in range this number, when my execution enter to this for block, I would like to sleep by 2 seconds, and also I would like to print one message. This is for to calculate the square, so I can write square, and to calculate square I can write I multiply by I, and it will return the square of the number I have provided. And also I would like to print current time, dot current time. Okay, so this is for finding the square. In the same way, I would like to create another function for finding the cube. For I in range this number, I would like to sleep for suppose 3 seconds here. To calculate cube, I can write I multiply by I multiply by I, or I can write I to the power of 3. And also I would like to print the time. Okay, these are my functions, find square and find cube. Now I would like to run my thread. I want my thread to execute this find square and find cube function at the same time. So let me create thread. First thread 1 equals, I can write threading dot thread, and I have to pass my function name. My function name is find square, and I can pass argument. It will take a number. I have to pass my argument in this tuple. In the same way, I can create another thread for cube, threading dot thread. I have to pass my function name. My function name is find cube. Again, it will take argument. I will pass 5. Okay, I have created this thread. Now to start my thread, I can write t1 dot start, t2 dot start. It will start my thread, and I would like to display one message: thread successfully executed. And I want to display this print message after both of my thread execution get completed. So here I can write t1.join, t2.join. That means it will wait for both of my this thread to get completed, and then only it will display this message: thread successfully executed. If I press shift enter now, you can see my square and cube function are running at the same time. See, my square, my cube, again square, my cube. So my both square and cube function are running at the same time. This is what multi-threading is. To run the tasks at the same time is the multi-threading. So this is how I can implement this thread. If you see here, I am passing argument 5, right? If I do not implement thread, then this find square will take 5 multiplied by 2. I am sleeping this for 2 seconds, so it will take 10 seconds, and this find cube will take 5 multiplied by 3, 15 seconds, right? That means it will take 25 seconds if I do not implement multi-thread. But with thread, it will take maximum time any of this function take. This find cube will take 15 seconds, and this find square will take 10 seconds. That means with this thread, my execution will goes for only 15 seconds. Without thread, it takes 25 seconds, and with thread, it takes 15 seconds to complete this execution. Okay, this is the importance of multi-threading. Next, we have multiprocessing. Same like as above, I would like to import multiprocessing and also time, and I would like to copy these two functions, Ctrl C and then Ctrl V, Now I would like to create two processes. The first one is P1 equals, I can write multiprocessing dot process. I have to pass my function name, find square, and my argument. Again same 5. Let me create another process. I can write multiprocessing dot process, function name, find cube, and again I have to pass my argument. Again same 5. Okay, now I will have to start my process. I can write p1 dot start, p2 dot start, and I want to wait for both of my this process to get completed, so I can write p1 dot join and also p2 dot join. And finally I will have to print one message: multiprocessing successfully executed. And also for this multiprocessing I have to write here, I have to write if name equals min, to avoid having infinite process. So I have to write if name equals min, and it will avoid creating multiple or infinite process. So you have to write your this code inside this if block. Now if I run this code, shift enter, you will see nothing. You will see only this print message multiprocessing successfully executed, because in this Jupyter notebook you will not get the expected output. So what you can do is, let me copy this code, Control C. You can go to your directory, any directory, and let me open here my Visual Studio Code, and here I would like to make one file with the name multiprocessing. And you have to know this, you can't save your file by name multiprocessing. Library name is also multiprocessing, so it will get conflict. So you have to write some other name. Okay, I'm going to paste my code here, Control S, and to run this code you have to write, for the command prompt you can write Python multiprocessing demo.py. Let me press enter. See, you can see your square function and your cube functions are executing at the same time. I am getting this multiprocessing successfully executed multiple times. So this is why this if block is very important. To avoid creating multiple process, you have to use this if block. And now if I put my this print statement inside this if block, and if I run my code again, cls, see, now my print statement will be executed once my execution get completed. See, both of my functions square and cube are running at the same time. This is how I can implement multiprocessing. So if you want your tasks to run at the same time, you can implement multi-threading or multiprocessing. Next we have async programming, asyncio. And if you don't want to use multi-threading or multiprocessing but want to run your tasks at the same time, then you can use this async programming. You can use this asyncio model. So in this async programming you can use this model asyncio, and it allows you to write code that runs concurrent tasks without using threads or process. So just now I have implemented concurrent execution with this thread or process, but if you want not to use this, you can consider this async programming. And it is ideal for IO bound tasks like reading files, web scraping, APIs, or network communication. Let me implement this async programming. Async programming will be using this model. So I can write import asyncio you import time, and I can create same function find square. It will take number. I can write for I in range number. Now I can't write time dot sleep because time will block my call, so I have to write asyncio dot sleep, and I can print square. I multiply by I, and also I can print the time. Now I can use this time model see time, and the new thing is I have to use async await. I have to use here async, and here I have to use this await. In the same way for finding cube, async def find cube. I will pass number for I in range number. Again asyncio dot sleep will sleep for 3 seconds. Print cube I to the power of 3. I like to print current time. And now I would like to create my main function. I would like to create one task. I can write asyncio dot create task, and I have to call my function here. I can directly pass my parameter 5, and let me create another task. Asyncio dot create task. This is for my cube. So find cube. It will also take one parameter. Let me pass 5, and now I can write await task 1, also await task 2. That's where for both of my tasks get completed, and then I can print async task successfully executed. Now if you are running this code in .py extension, you have to run your code with this command or with this code. You have to write asyncio dot run, and then you have to pass your function name main. So to run your main function, you have to use this code in your normal .py file. Right now I am in Jupyter notebook. I can simply write await main, because in Jupyter notebook or in Google Colab there is already an event loop running, so I don't need to write asyncio.run. I can simply write await main. Now if I press shift enter, okay, there is one syntax error. I have to make it correct. Let me press shift enter again. Okay, see, again my square and cube function are running at the same time. So if you don't want to implement thread or process, you can use this async programming. This is it. So async task successfully executed. Next one is context managers with statement. And these context managers are used to properly manage resources such as files, network connections, or logs, and it will ensure they are acquired and released cleanly even if error occurs during use. And the most commonly way to use a context manager is through the with statement, and the syntax is you can write with expression as variable and you have to provide your block of code. So to manage your resources, you have to use context managers. This will be most useful in file system. Let me explain this through the code. Context managers with statement. Now first one, let me explain this without using with. Suppose you have one file, open student.txt. I have already created my student.txt file, and it will contain small text. This is student dummy file, this is my student.txt file, and this is in my same root directory. And here I would like to open that student.txt file. In a read mode, I can use try finally block. Here I can read my file, so I can write file.read and I can print the content. And the major thing is, after I read the file, I have to close my file manually. So in this finally block, I have to write file.close, and this is compulsory. So if I press shift enter, I can see this is student dummy file. So my student.txt file contains this text, and I'm getting this here. This is student dummy file. This is without using with. Without using with, I have to close my file manually. Now using with, I can write with. I can open my file students.txt in a read mode as file. I can read my content, read my file, and I can print the content. As simple as this. Now I don't need to close my file manually, because after my execution goes out of this with block, my file will be closed automatically. So this with keyword is used for managing resources. If I press shift enter, see again I am seeing the same output. This is student dummy file, and here the code is more refactored. I don't need to close my file by myself. Now let's see some real world example. ATM transaction. How can I manage resources in this ATM? Using context manager. I like to make one class here, ATM transaction. I like to define one method, enter. It will be executed when I call this, when I created object of this class. It will be first called enter method, and here I can print one message. Locking ATM for transactions. Transaction. I can return self. Next, I have exit method. Self, exception type, exception value, and exception traceback TB. And here I'm going to print one message releasing ATM lock. I'm going to create last function withdraw self amount, and I'm going to print one message withdrawing this amount. Okay, now when I call this function withdraw, before printing this message, it should go to this enter block, and after printing this message, it should go to this exit block. I'm going to use with keyword again. With my class name is ATM transaction as ATM. I can call my withdraw function. Now if I press shift enter, you see when I'm withdrawing amount 500, then the first step should be it should lock ATM for transaction. That means other person should not be allowed to use the ATM. And after I withdraw this 500, then it will again release the ATM log. so that other person can now use the ATM. See how the resources is managed here. When I'm calling this function withdraw, then this enter and this exit method is called automatically, and the timing is before this withdraw function, this enter function will be executed, and after this withdraw, this exit function will be executed. This is how the resources can be managed. Also, I can implement this using context leave. I can write a comment here using context leave. What is this? I can import this module from context manager, and here I am going to create one function ATM lock. Same. First step is enter this enter block, right? So it will take same this print statement, Control C, Control V, and now I am going to use try block, and I have to use here yield keyword, yield, yield keyword, and also I have to pass finally, and I can print this exit block. That means here also when I call this withdraw function, number one, it will execute this enter block, number two, it will execute this withdraw block, and number three, it will execute this exit block, right? In the same way, here also it is executing this enter block, and in this yield keyword, this is my with block. I will be defining with block after this function. So here I can write comment. This is where the with block will execute. That means it will execute my this block. I will be defining later. And finally, this is my third step, exit block. It will release ATM lock. So here I can use with block with. I can call my function ATM lock, and here I am going to print withdrawing suppose 500. Right now I am passing this manually. So both of these code are same. Here this is my enter block, and in this yield keyword my this code will go. So my with block will be executed here, and this is my final block. This is my exit block, and I have to use this context manager here. So I can write iterate context manager. Then only this yield keyword will work. If I press shift enter, from context leave I have to import context manager. Let me press shift enter again. Okay, the code is same. You can see here the output is same. So the important point is you have to know for what purpose this context manager is used. Context manager is used to manage your resources, and to manage the resources you can use with keyword. You can use with keyword to manage your file system, and this is the real world example. In the ATM section also this context manager can be used to manage the resources. This is all for this video. In this video I have discussed about decorator, generators and iterators, metaclasses, multithreading and multiprocessing, async programming and context managers. So these all are the important concepts in Python, important advanced concepts in Python. I hope this video is helpful to you. If you like this video, hit the like button, subscribe my channel IG Tech Team. I will meet you in the next one. Keep learning.